So in this question we have refraction of light. It's going from medium 1 to medium 2. And the question is telling us that while it's in medium 1, we have frequency 1 and wavelength 1. When it's in medium 2, we have frequency 2 and wavelength 2. Alright, and the question is asking to find out which one of the options here is necessary for total internal reflection to occur. Now, total internal reflection is something that it's only possible when the light is moving from a more dense material to a less dense material. So if it's moving from a more dense to a less dense, then the light or the wave is always going away from the normal. So if I keep increasing the angle of incidence, then the angle of refraction will be increased as well until I reach the maximum, and then if I pass the critical angle, I will have a reflection. The reason it doesn't occur in the other way around, the reason it doesn't occur from the less dense to the more dense, is that it's always moving towards the normal. So even if I increase the angle of incidence, there's still space for the light to reflect. Right, so definitely in order to have this total internal reflection, we have to say that it's moving from more or less to less dense. Now, when the light moves into a more dense, in a more dense material, then the velocity is slower comparing to the velocity that it's going to have when it's moving to a less dense material. That's going to be faster. Yep. Therefore, we have to kind of use the velocities of the two velocities in medium 1 and medium 2. Remember that velocity is frequency times wavelength, and the velocity on the second one is the same. So as we mentioned, in the more dense material, it has to move slower than the less dense material. So V1 is definitely less than V2. Now, the frequency of the wave, it doesn't really depend on the medium that the wave or the light is going through. The frequency is defined by the source of the wave, the source of light. So in that case, the frequency in medium 1 and medium 2, it's supposed to be the same. Yeah. So as I said, frequency depends on the source, not the medium. Therefore, the frequency is the same. So this F is the same. The only thing that can actually change in that case is the wavelength. So if I kind of remove the velocity from there, I still have this relation that frequency times wavelength on medium 1 should be less than the frequency times the wavelength on the medium 2. And if frequency is a constant value, therefore I can say that the wavelength in the first medium is smaller to the wavelength of the second medium. Right, and this one is described by C.